Good morning again. Let me come till now. We have covered in under module. We have reached up to strain rate, I guess. Just a second. We have covered temperature effect in metal forming. Okay. Yes, up to this. Okay. So today we are going to start, strain rate, how the strain rate affect your flow stress. Okay. So, and immediately after that, this module will end up. There is one more small topic that is role of friction. So it will hardly take 10 to 15 minutes. Okay. So without wasting the time, let us start to this discussion, that is strain rate. Okay. The strain rate is the rate. I have already written the important statements in PPTs itself. So the strain rate is the rate at which the deformation occur. That is, it is the rate of deformation. So whenever we are talking about the rate of something or rate of deformation, it is something per unit. Okay. So when we want to measure the rate of deformation, or rate of strain, it means it is per unit time. Okay. So this is in how to measure this strain rate, or how to observe strain rate during the metal forming deformation. So it is normally given. This is equivalent to instantaneous strain or change in strain per unit time. Okay. So this is usually denoted by epsilon dot is equal to delta epsilon upon delta t. So what does it is denoting? It is denoting the change in strain, instantaneous strain, and the time interval. Okay. So this ratio gives you the instantaneous strain per unit time, or you can say strain rate. Why this strain rate is important, we will try to understand. Okay. So let us try to see the effect of strain rate on flow stress. Okay. The effect of strain rate on flow stress, that is sigma f, at fixed strain and temperature, it may be given as sigma m is equal to C multiplied by epsilon raised to the power m. Okay. So here C is again a strength coefficient. It is similar to your strength coefficient, but it is not equal to your strength coefficient. It is a constant. Okay. Then m is your strain rate sensitivity exponent in the case of this particular equation. You can also express flow stress as a function of strain and strain rate. So suppose this is sigma m, again flow stress may be denoted as sigma m equal to a multiplied by epsilon raised to the power n, and epsilon dot raised to the power m. Okay. So again, A is a strength coefficient, and which is the combining effect of the coefficient K and C. So this is your coefficient C, which was similar to strength coefficient, but not equivalent to or not equal to strength coefficient. So the combined effect of your K and C is represented here as A by a new constant. Okay. So I have directly taken these formulas. I have not gone through the how these formulas were derived by different researchers, but for the importance of or the understand the effect of strain rate on flow stress, these formulas has been taken directly, and it will be used or in your numerical problem. Okay. Then, as I told, today we have connected topic, that is the friction in metal forming. Okay, so I have two more slides to explain. After that, I will stop my discussion. That it will be end of module 1. Okay, and then it will be followed by a numerical problem. So, talking about friction in metal forming. So normally friction in metal forming arises because of the close contact between the tool and work surface and the high pressure that drive the surfaces together in these operations. Okay, so let us try to understand what happens in the case of any forming process. Let us take one example. Okay, suppose you are having a extrusion die, something like this. Let me draw the diagram. Okay. Suppose you are extruding some material from this die. Okay, this is your chamber. Okay, and your material is coming out of this die. Okay, this is your die opening. Okay, so for extrusion, what you do, you apply pressure from this side. Suppose you are applying pressure P, and the material is getting extruded through this die opening, and this is your die opening, and your final shape is like this. Okay, so your final shape is this is your final product. So try to see here what is happening from this place to I hope. Let me change the color so that you are able to understand with more clarity. Okay. So at this interface, that is the work part and your tool interface, what is happening? These two surfaces are in contact, like your this is your tool part and this is your metal workpiece, which is getting deformed. Okay, so at the point of contact, or these are the surfaces which are in contact with each other, and this surface is moving in certain direction, that is from if I take this diagram, it is moving from left to right. Okay, so since these two surfaces are in relative motion and they are in contact with each other, so obviously they will have certain frictional force. So let me ask you the simple question. I think you all of you might be able to answer. Since there is a friction between these two forces, this friction is desirable or non-desirable phenomena in the case of this extrusion process. Any students, if you can respond?
Sir, desirable.
Yes. Okay. Anybody else? The friction is opposing the movement of or the flow of your material in your desired direction. So it is a desirable things or undesirable. Any other student? Okay, let me cross check. Abhishek, Altmas, Rahman, Aman, all three of you. Oh, so I think you are not listening. Amit Kumar.
Sir, I think it is undesirable, sir.
Okay. Ankit Bhatt.
Sir, sir, I think it is undesirable.
Okay. Okay. Any explanation why it is undesirable?
Sir, because it is opposing the motion of we want that extruded.
Okay, fine. So I hope it is clear to all of you, because the material is flowing in certain direction, and your frictional force is opposing the movement of your flow of material. So in most of the cases, the friction is undesirable. Okay, in particularly talking about metal forming processes. Okay, so why this friction is arising? This friction is arising due to the close contact between the tool surface as well as your work part surface, or your surface of your metal block. Okay, so in this portion you can see whenever your metal part or work part is trying to slide or trying to flow in the desired direction, your contact with the tool part is opposing the flow of your material. Okay, so let me come to the again to the slide. Okay, so in most of the cases, the friction is undesirable. The reasons are: the material flow in the work is retarded, that it is opposing the flow of your material. Uh, the force and power to perform the operations are increased. Okay, so obviously, since there is a opposing force, so the force and power requirement will increase in the case of your or due to the frictional force between the tool and your work surface. Then one more issue is there. This is not only the this frictional force is not only with your work part and your die surface, but it is also with your tool also. Okay, tool part. So what happens? Suppose because of friction, there is opposing force, and due to opposing force, obviously there is some damage to your tool surface. Okay, so or your die surface, because it is rubbing over this surface. So what will happen? Ultimately, it will damage your die. Okay, suppose you have placed die here, and this is your die. So what will happen after certain time of after certain interval of application, your die size may get increased, or it may have certain damages due to the frictional forces between your tool and die, right? So again, this is another disadvantages or the reason why your friction is undesirable in the case of metal forming processes. Okay. For cold forming, it is fine, but think about your hot forming case when you are deforming your material at a higher temperature, or when you are deforming material at temperature which is above your recrystallization temperature of your metal block. So in that case, your tool part is also get heated, like your tool and die is also heated. So due to heating of die, the damage in your tool part will also increase. Okay, so sometimes it is becomes a severe problem, or it becomes too large that you need to frequently check the die and tool surfaces. Okay, so friction and tool wear are more severe in the case of hot working. Okay. One more thing, if the coefficient of friction becomes large enough, a condition known as sticking occurs. Okay, so let me explain what is sticking. Sticking in metalworking is the tendency for the two surfaces in relative motion to adhere to each other rather than slide. Okay, so there may be the situation that instead of these two surfaces getting slide in the desirable direction, they stick to each other. So in this condition, what happens? Your material flow get blocked. Okay, the material is not moving in your desired direction due to the large, large amount of your frictional force. Okay, So your material, since your material is not flowing in your desired direction, your process is stopped, and this condition is called sticking condition. Okay. So in the case of sticking, they both the surfaces, that is tool surfaces or die surfaces, tool and tool die with your work part, they get stick to each other instead of sliding on your tool surface. Okay, so that is why we can say the friction is undesirable thing in the case of metal forming processes. And how to overcome this undesirable things, that is the frictional force in metal forming processes. We use a certain kind of lubrication. Okay, so the connected topic, that is lubrication in metal forming processes. Let me read. Metal working lubricants are applied to tool work interface in many forming operations to reduce harmful effect of frictional or harmful effect of your friction. The benefits obtained from the application of lubricants are reduced sticking. It is quite obvious that when these two surfaces are lubricated by a suitable lubricant, then the problem of sticking, that when the thing that the two surfaces were getting adhered, the chances will be reduced, as well as since the opposing force is reduced, your force required to deform the material will also get decreased. Then your power requirement will also get reduced, as well as since there is reduced forces, the tool wear will also get reduced. Due to lubrication, you get better surface quality, or you can say better surface finish. Lubricants sometimes also carry away heat generated from the toolings, and this also serves, you can say, to improve the tool life of your metalworking processes. Okay. Then coming to the next, that is how to choose appropriate metalworking lubricant, or the lubricant for your metal forming process. So it depends on many parameters. First one is type of your forming process, whether the process is hot working or cold working, work material properties, chemical reactivity with tool and between the tool and your work material, ease of application, and in last, obviously, the cost factor, which lubricant is easily available or is less costly. Okay, so this is you can say your